everybody. We are here on lesson 3.4, keeping Barbie safe. I apologize, I don't have my earbuds, so you're going to hear my stylus a little bit more this time. What we're doing here in this lesson is we are kind of being quality assurance for Barbie to keep her safe. We don't want her crashing down and hitting her head when she bungee jumps. So we have the question here of how can we be sure that the bungee cord that we make for Barbie when we drop her down the stairwell will keep her safe? Should we be worried in any way? We want to be confident that we're safe, okay? What if we entered data incorrectly? What if we had the wrong units? You'll see as we get into this. So below is data for one group's Barbie bungee. And I've already taken a minute and I've put it into the Stats Medic applet, okay? Make sure you choose to quantitative when you do that. I will show you that I've already done that here. Bada bing, bada boom. It's to quantitative, and make sure you put commas or spaces between your numbers, okay? And what we're being asked to do for Barbie here is just run it and get the correlation. So, and then based on that, how do we feel for Barbie? So begin my analysis. There it is. Nice little scatter plot. Correlation, 0.992. Okay. That's a pretty strong R value. All right. Since R is 0.992, I feel pretty safe. And I think Barbie should too. If you're bungee jumping, you want the correlation to be strong. So this would be very safe because we have a strong linear relationship. Okay. If you got a really low R value, say like 0.3, it would mean like, this explanatory variable is not very predictive of the response variable. And if it's not very predictive, I wouldn't feel very safe putting my faith in this. Okay. Number 2, it says one of the group members made a mistake and they switched these two when they put it into the table. Will that matter? If we go back and we switch these, will it matter? Think about it before you go ahead and do it. Is it going to make a difference? Essentially, like, you have your dots, right? And it looks like this. And you had rubber bands down here. And we had distance over here. Will it matter if I flip these? The dots are all going to be relocated. Will that make R different? Now that you've thought about it, make your guess. You might want to just fast forward this, skip ahead. Yes, I want to get rid of all those. And I'm going to reverse them, okay? So this now becomes my distance. And this one becomes my rubber bands. Rubber bands. All right. We keep them in the same order, though. So 12, 14, 17, and so on. I think I got all those. And then this is the easy one. 0, 1, 2, 3, 4, 5, 6, 7. So I just reversed them. And hit begin analysis. And hit calculate it. Oh, look at that. Now, if you are quick and good with your vision, the scatter plot has been reflected because I flipped the two axes, but the correlation coefficient remains exactly the same. It's 0.992. Okay? It's the same R of 0.992. So switching X and Y does not change R. Okay. What about other things you might have messed up? So, or done differently. Messed up's not the right word. What if one group measured everything in inches? Maybe their meter stick was taped on the wall backwards. So they had everything in inches, and so to multiply that, or to fix it, they multiplied the inches by 2.54 because that's the conversion. They've already done that for us here, so they took 12, and this is inches, and multiplied it by 2.54 to get this. 14 inches and multiplied it by 2.54. So they did that over and over. They've done all the heavy lifting and the grunt work for us. Will that matter? What do you think? Do you think changing the units will affect the correlation? Again, we're going to go through and do this and get our answer. All right, so back to my data. I might just start over. That was easier. Two quantitative variables. Explanatory, we'll go back to the original way we had it. Rubber bands. Response is distance. And 0, 1, 2, 3, 4, 5, 6, 7. Now this one I have to enter the numbers in centimeters that they have there in your notes. 30.48. You can just fast forward if you don't want to. Listen to me. If I get this without a mistake, I'll be impressed. All right, here's hoping. Begin analysis. There's my scatter plot. And then here's the kicker correlation. Yes, I did it right. It remains unchanged yet again. Okay, so cool. So it is again the same R again. Same R of 0.992. So what does that mean? Changing units on one or both variables does not change R. Okay, cool. How about this, number 4? One group member snuck an extra rubber band and collected more data, those little sneaks. They put 15 rubber bands on Barbie's around her feet and dropped her, and they got an answer of 124.5 centimeters. We're going to add that to our scatter plot. How do you think that point is going to affect the correlation? So essentially, here's what's happening, right? Here's my a sketch of my scatter plot. Well, here, I'll just make it. Again, you can pause this if you'd like, or just add that person in. So we add in a 15, and in the and then a 124.5 for the distance. Okay. Begin analysis. There it is. So look at that. We got that dot way out there. Okay. We've talked about this earlier. That dot way up on the right is an outlier. Whether or not it's influential is to be determined. So we've got like all these dots that are really closely clumped, those 6 or 7 dots, and then we have that one way up here. All right. What's going to happen to R? Well, Hit begin analysis. Boom. 0.998. Well, that's pretty close. Didn't change a whole lot. The new R equals 0.998. So it got, I guess, it got a little bit stronger, but not much. And it changed very little. Changed slightly. And why is that? Why did it change slightly? Because here, before I added that extra dot, the red line would have been the line of best fit. If I then have to get and incorporate this dot, now the line of best fit gets extended, so to speak, and it pretty much goes right through that. So this is an outlier, right? But it is not influential, is what we're trying to say. Okay. Number 5. One last possibility. One group accidentally left off a digit on one of their numbers. When they did the 6 rubber bands, they got 66.04, but they left off one of the 6's on accident and they entered 6.04. So that would be this guy right here. What if they entered it wrong? All right, so I'm going to go back to my data and ask what happens there. Let me copy this. Copy. Paste. Okay. So now let's get rid of that. Okay. And I'm focusing in on that one dot, and it's going to drop from 66 down to 6. So let me see if I can try to estimate this. I got 1, 2, 3, 4, 5, 6, right? And so this dot, let's say it was this one, the 6th dot. It's going to move and drop down. I did it again. It's going to drop down significantly. It's going to come way down here instead. This would be the 6 and then 6.04. Okay? And it's way down there. So let's see what happens. I gotta find it in my data. This one right there. Make that 6.04. There we go. And I'm gonna remove. Oh no, I guess I'm not gonna remove that extreme data point. I was reading the notes wrong. I'm leaving the 15 and the 124 there. Okay. I'm gonna hit OK. Yes, I changed my entries. Begin analysis. So there we go. See that dot at 6 dropped way down. What is that going to do to my correlation coefficient? Well, it's probably going to have a much bigger effect than that dot way up on the right. So hit that correlation calculation button and we get 0.789. So that dropped quite a bit. Okay. Oh, I did all that in the wrong spot. Fig. I did all of this in the wrong spot. You'll have to forgive me. I meant to do that all down here. So just a quick sketch. We've got the line going here. And I dropped that one dot way down to here, and I still have that outlier up there. So these are both outliers, both of these red dots, okay? But this one has a new R of 0.789, which is quite a bit weaker. Okay? If you go, so in other words, this is an outlier and it's influential. It's both. And again, this one up here was an outlier, but it was not influential. We're not moving that one down there. That was my mistake earlier. Sorry about that. Okay. So there are different effects an outlier can have. This one didn't really do anything to the R value. It got a little stronger. This one had a big effect. It dropped like 0.20. Okay. So there you have it. Quick notes. Learning targets. Number 1. LT number 1. If you want to calculate R, you can either use the TI-84 to practice for the exam, or use the applet, and it's too quantitative. Variables on the applet. Okay. And you should be familiar with how to do both. TI-84 is necessary for your exams. LT number 2, learning target 2, properties of R. We did learn a lot of them as you went through the notes. One of them is correlation makes no distinction between explanatory and response. Because when we switched the x and y variables, R did not change. We also converted from inches to centimeters, and what did we learn there? Is changing units does not affect R. Does not change the value of R. Okay. And number 3, what we're really getting at with all of this is R has no units. It's not like inches or feet or miles or centimeters or anything like that. Okay? And last but not least, see if I can get it to fit over here. LT3. What about outliers? What did we learn about them on those last 2 questions? Outliers within the pattern strengthen the R value. They strengthen R, meaning it will get closer to 1 or -1. That was when we added this one up here. It went from 0.992 to 0.998, so it got slightly stronger because it was within the pattern. Okay? If they are outside the pattern, they are influential, and they will change R. They will weaken R. I shouldn't say change. Outside of the pattern, weaken R, which means it will get closer to 0. Okay? And that's what happened on this one right here. This was outside the pattern, so it brought R down quite a bit, a lot. So there you have it, folks. Now you know a little bit more about R. Thank you. Hit that subscribe button.